Okay, here we are, page 1 of logic bookwork. These are really quick pages, so we're going to do more than usual. A simple statement has a truth value of true or false, but not both. Which of these are statements? Ria studies Malay. Yeah, that's a statement. Yeah. Could be true or false. Make the tea. No. Make the tea is not true or false. 5 is greater than 2. Yeah, that's true, as a matter of fact. 2 is less than or equal to. Yeah, that's true. So, statement is the sun is not shining. Yeah, it's either not shining or it's shining. The moon is made of green cheese. Yeah, that's false, so it's a statement, right? A week consists of 5 days. That's false, so it's a statement, right? If we go back and look at these, maybe you might say, hey, sun is not shining. Maybe that might not be true or false. Maybe it's kind of both, but, you know, um, basically that's a statement. Okay, now we're going to talk about exclusive or and inclusive or. What's the difference between an exclusive or and inclusive or? Um, I'm just going to write or like that, and I'm going to write exclusive or like that. Um, let's say that you say in IB you can study chemistry or physics. Um, you can also study both, right? So that would be inclusive or. Okay, if you can study both, then it's inclusive or. What about like you can study in IB Math HL or Math SL? That would be exclusive or because you cannot study both. So exclusive or means you cannot study both. Okay, so let's remember that as we do the next exercises in 9B. Your mother is either Argentinian or Chilean. Um, so if we think, okay, can't be double nationality, then we'll say, yeah, that would be inclusive or exclusive or. Okay, now if you say, oh, maybe she could be both Argentinian or Chilean, then maybe it could be inclusive or. So this one might be both, right? Do you take milk or sugar in your coffee? Um, here's another one. You know, like some Americans take both, right? So depends on where you come from. He is allowed either food or drink after exercise. Okay, so that means he can have both also, right? So if he can have both, then that would just be inclusive or. Under the terms of your lease, you may use the land for either residential or business purposes. Okay, so you got a piece of land, and let's say it's a small piece of land. Then you're going to either use it for a store or you're going to use it for a house. So we'll say exclusive or. Now, if it's a really big piece of land, maybe it's going to be used for both. So, okay. He's a captain in either the Army or the Navy. It's pretty hard to be in both at the same time. So we'll just say exclusive or, right? Knowing that x minus 2 times x plus 1 equals 0, we know that x is equal to 2 or x is equal to negative 1. Can x be both 2 and negative 1? No, it can't, so that would be exclusive or. Okay. So the system used in math and logic is, if you use the word or in a statement, it is always going to be inclusive. Okay, so to use the exclusive version of or, you must use the extra phrase, but not both. Okay, so the ones above were, you know, sometimes I was like, oh, it could be either one, right? But in math, they're always going to try to make it so that it's very clear. It can only be exclusive or inclusive or. Okay, so write the negations of these statements. Now we're going to talk about negation, which means, you know, something is not whatever. Okay? Um, so we're just going to try to change these sentences so that they're negations. The student is not a council member. N is not a prime number. Surabaya is not the capital of Indonesia. Write negations of these statements without using the word not. Ooh, that's kind of tricky. This word starts with a vowel. So how can we say that without saying not? Well, we could say this word starts with a consonant. This price is inclusive of sales tax. Okay, so we could say this price does not include sales tax. Or we could say, oh, we're not supposed to use the word not. Oh my gosh. This price is exclusive of sales tax. He walked at a constant speed. So he could say he walked at a varying speed. Okay, I think there's a couple ways you could do that one. Okay, in these statements, is Q the negation of P? If not, say why it is not the negation. Okay, and this is kind of hard to understand the instructions, but if you do a couple, I think you'll get it. As you can see, we're going into page 3. If not, say why it is not the negation. Okay, so P. Chihiro obtained the highest mark on the test. Now, is that the negation of Chihiro obtained the lowest mark on the test? Well, let's test it. For P, let's try to make it negated. So we'll say Chihiro did not obtain the highest mark on the test. Did not obtain the highest mark on the test. So what marks could Chihiro have gotten? Could have gotten any of the marks except for the highest mark, right? The negation of this is not getting the lowest mark, it's not getting the lowest mark. It's getting any other mark besides the highest mark. So that's why, right? So like you could say maybe Chihiro got a middle mark, okay, not the lowest mark. Okay. Sahana scored more than 50% of the test. Is that the negation of Sahana scored less than 50% of the test? Well, let's see. So Sahana did not score more than 50% of the test. So that means, is there a case that's not included here? Yeah. What about Sahana got exactly 50%, right? That would also be a negation of P, but it's not included in Q. Okay. So you can see that putting not in is not the same sometimes as like maybe rephrasing it. Sometimes when you rephrase it, you end up changing the meaning a little bit. Nishad scored above average on the test. Nishad scored below average on the test. Is there a case that's not included here? If you say Nishad did not score above average, then you could have the case where Nishad got the average, right? Nishad got the average. Okay? All right. In all the questions above, Q was obtained from P by using the opposite word. Does this method always give the correct negation? No, in fact, many times it does not, right? No. In I, replace obtained in P by did not obtain. Is the resulting statement the negation of P? Does this method always give the correct negation? So, yeah, so they're saying like, oh, if you put, oh, not up here, down here. So if you put Chihiro did not obtain the highest score on the test, or Sahana did not score more than 50% of the test, is that exactly what the negation should be? And yes, that's true. So if you put not in, then yeah, it always does give you the correct negation. Now, what's the disadvantage? Sometimes it gives you like a really weird sentence, right? So that's why we frequently do not do that, right? Write negations of these statements. So x is greater than 5. So we could say x is not greater than 5. Z is at least 10. Now we could say z is not at least 10, but that sounds really awkward, right? So can we try to say it in different words? We could say z is, let's see, at least 10 means it's like 10 or more, right? So maybe we could say z is less than 10. Is that okay? Yeah, because like if it's 10, then this is true, and if it's not 10, then this is true. So, or if it's less than 10, yeah, okay, that's all right. 5. The definitions of positive and negative are x is positive whenever x is greater than 0, and x is negative whenever x is less than 0. Is 0 positive or negative? It's neither. Okay. Write down the negation of the statement x is negative given that x is all the real numbers. Remember, the real numbers are pretty much every number we use in this class, okay? Including irrational numbers, which you probably don't remember anymore. Irrational numbers are like pi and square root of 2. Write down the negation of the statement x is negative. So our tendency is to write x is positive, but then we just said that 0 is not positive or negative and it's a real number, so we need to take care of that too. So the negation of that would be x is not negative. Or we could be more specific. We could say x is 0 or less. Or we could say x is less than or equal to 0. Okay, those are the possibilities. I'm sure you can think of more. Write down the negation of P for each statement P. Avoid the word not if you can. Now remember, when you use not, sometimes it gets kind of awkward. So Courtney was not absent from school on Friday. So you say Courtney was present at school on Friday. Okay. The hockey team lost their match. The hockey team did not lose their match. So we might, say, hey, hockey team won their match. But remember, like in hockey, I think you can tie. So you could say hockey team won or tied their match. Okay. The hotel does not have running water. Hotel does not have running water. Hotel, so actually you could just like take out the not there. They said not to use not, so if we take out not, that's fine, right? The hotel does have running water. Okay. His signature is illegible. Well, we could just be tricky here. We could take out ill, so now it's just legible. His signature is legible. The class contains fewer than 8 boys. Let's see, what if we put more than 8 boys? Now, we just need to be careful about the case of 8 boys. We want to include that too. So we could say contains 8 boys or more. He has at least 2 sisters. At least 2 sisters means 2, 3, 4, etc. So he has less than 2 sisters. You might also say he has 0 or 1 sisters. Okay. 8. The wording of a negation may depend on the universal set that has been given. If possible, write down the negation of these statements in the given domains without using the word not. Okay. So let's say, X is a female doctor. Okay. If the universe is all the doctors, that would include female doctors and male doctors. So we could say X is a male doctor. Male doctor. X is a married man given that the universe is all the married people. So in married people, there are married men and there are married women. So X is a married woman. So you might think that the negation here is X is not a married, or X is a unmarried man, but that is not in the universe of married people. The married people universe only has married men and married women. So the negation of X is a married man would be X is a married woman. Okay? Okay, so last, I think, for this problem set is R is a positive rotation of more than 90 degrees given that U equals positive rotations. So U are all the universe of all the positive rotations, and they're saying R is a positive rotation of more than 90 degrees. So if all the positive rotations can be like any number of degrees, and they're saying R would be more than 90 degrees, so we're going to say, well, the other possibility is R is a positive rotation because we're saying the universe of positive rotations. X is a positive rotation with less than 90 degrees. Okay? A rotation is like if you have like a function, let's say you got like some shape here, and then you rotate it, it like goes around the axis, and so it may look like this, or it may look like this. Okay, that's a rotation. And that's it for today.